Righto, Year 12, just having a look at some of the work we did last lesson and looking at these logarithmic equations or expressions because they don't have an equal sign. Now, we did most of the ones from 1, 2 and 3. I'm going to do one of the ones from 3 here again that we did, which was 3J, because I'm a bit worried that you didn't really understand that. So I'm going to do it again. I'm going to leave question 4 and then I'm going to do a selection of ones from questions 5 to 16. Because remember, question 4 is just calculator work. So let's have another look at this. So if we look here, this is log to the base 2 root 2 on 4. I'm going to put that in parentheses so that you know that it's all in there. And remember, this is our golden rule. If y equals a to the x, remember your BAP, base answer power. Well, then you bring that x down, because that's what you want to find, and that equals log of any base, or not any base A, y. And that's our law for all of this. We're going to learn some other laws in the next exercise, but we'll stick with this now. So let's have a look at this. Now what I'm going to do is I'm going to allocate a pronumeral for this, and I was using m in class, so I use m again. I'm just going to say m equals that. So therefore, using that same identity that I've got and going backwards, that means 2 to the m equals root 2 on 4. And immediately you're thinking, oh my God, how am I going to do that? You've got to understand that you can write 2 to the 4 in base 2 in index notation. Well, root 2, that's pretty easy. That's 2 to a half, we know that. And 4 we can write as 2 squared. Now, 2 to the m, I'm keeping that there because I formed an equation. What do I do when I divide two indexes with the same base? I subtract the powers. So it's 2 to a half minus 2 to the 2, which gives me 2 to the 1 and a half. Well, I'm going to write 3 on 2. Please understand that 1 and a half is 3 on 2. Therefore, that should be negative 3 on 2, is negative 3 on 2. And that's one we did in class because I think we went through that rather quickly. Now, I'm not going to do any of the questions in 4 because that's just calculator work. And if I pull up my calculator, for example, look at the first one, log base 10, 1200. All you do is you hit log 1200 and you hit equals. And what do they want it? To 2 decimal places. H, log 9 ln, remember ln is log to the base e, so we've got ln 9.8, close your bracket, plus log 17. There you go. And remember, it's 2 decimal places. So I'm going to move on from there. I'm going to have a look at some of the other ones because that we didn't get to. I did a question from 5. Remember, you're only doing every second one, so I'm going to cruise down A, C, E, G. I'll just do G. So this is 5G. And what do we got? We've got y equals 6 to the x. And they want me to write that in log form. Well, x becomes log to the base 6, y. Sweet, done. Very easy. Question 6, going back the other way. So if I take 6a, what do we got? Log 3 to the 5 equals x. And you can keep referring to this over here to help you with it and go, oh, what goes where? Or you can remember the base answer power. So that just means 3 to the x equals 5. All right. Essentially, if you remember that the base stays in the same spot, you'll be okay. What else we got? We'll do another one from 6. Let's do J because it actually comes up later on in exponential growth and decay. We've got Q equals e to the x. Well, that means x equals log to the base e q. And remember, log to the base e we write as a shorthand as ln. So if the answer's in the back of the book, we've got ln, you'll have to use that. Now, how are you going to do question 7? Let's have a look at question 7. So we'll have a look at 7a. And we've got this log to the base 10, x equals 6. So what do we need to do? Well, let's rewrite that. Let's rewrite that as x equals 10 to the 6. Well, okay, well, that's easy. That's just a 1 with 6 zeros, which we know is 1,000,000. Well, why don't we check that? Why don't we just do log of 1,000,000? We'll pull your calculator up and see if we get log of 1,000,000. So 1, 2, 3, 4, 5, 6. Did I type in too many? 1, 2. I think I typed in 1 too many. 1, 2, 3. There we go. Oh, 6. I know I'm right. Please make sure you use that on your calculator. If I look at some of those other ones, and of course they start playing with the index laws. So A, C, E, G's decimal, but that's pretty easy. Remember that ln, well, I'll do G. What is it? ln x equals 3.8. So ln x equals 3.8. Well, we know that ln is E, so it's x equals E to the 3.8. So I'm going to have to use my calculator, but that's okay because my calculator has the E function on it. But remember, you have to hit Shift. So Shift ln, and I put my 3.8 in, and I get that. Now, how do I know that I'm right? Well, if that's what x is, what is it? 44.7. 44.7. If I go the log of that, so if I just go ln my answer, I should get 3.8. Oh, yes, I do. So I know I'm right again. So there's 7. So let's have a look at these. 8's going to be the same. They're just going to be variations of these. Beta 3 significant figures, find the value of... I want to have a look at 12. Because 12 is going to illustrate something to you that you're going to find out next lesson. So evaluate log to the 5. Well, log base 5 of 5. So we'll call m equals log 5 of 5. So we rewrite that. So 5 to the m equals 5. Oh no, Mr. Tonkin, there's nothing there. Please remember, if there's nothing there, it's not nothing, it's a 1. So 5 to the m equals 5 to the 1. So m equals 1. M equals 1. And then they say, well, what's log a to the a? Well, you can do the same thing. You shouldn't need to because you know it's going to be 1. I better not use in the same question the same pronumeral, so I'll throw in n. N equals log a to the a. Well, that means a to the n equals a. Well, there's nothing. No, come on, you're better than that. A to the 1, which means n equals 1. Now, how can I test that? How do I know if I'm right? I think I've worked it out. Go to your calculator and just go log 10 of 10 and ln of e. Log 10 of 10. We'll just do log 10 of 10. Does it? 1! Yay! And let's do ln. You have to use your shift button and you're going to have to put a 1 in there. And press 1. All right. And now you've learnt a little law that you can highlight and put in your notes. If the log is of the same base, then it equals 1. 13, that's all calculator. All right. And when you see log to the base, you just use ln. All that's calculator. So you should be right. Now, you did this when we did it in year 10. This is a relationship. This is a relationship between, go away. This is a relationship between y equals e to the x and y equals ln x. All right. So you should know how to sketch these. These are really easy. And the same with y equals 10 to the x. Remember, they are inverse functions. So I'm going to do question 15 so quick. You should be able to do it just as quickly. So I'll just draw myself a little set of axes here for 15.